Let's see this question. Construct a Java program to demonstrate single inheritance. Question A under cycle 4. Before going to single inheritance, let's see what is inheritance. Inheritance is a process of acquiring properties and functionalities of one class into another class. Okay. Uh, what do you mean by properties? The data members, the instance variables of a class are called as properties, and the methods defined in a class are called functionalities. It is also known as behavior sometimes. See here. Here there is a class called calculator. We have declared two variables a and b of type integer. This a and b are known to be the data members, nothing but properties, and these functions add, subtraction and remaining methods. These methods are known as functionalities or behavior. Okay. It's a process of acquiring these properties and functionalities from one class to another class. The class in which the properties and functionalities are defined is known as parent class, and the class which is trying to acquire the existing functionalities is known as child class. Let's see why we need inheritance. Generally, inheritance will give us reusability. There is functionality already defined, and if I need to add some more functionality to that, why do I repeat and design the same code again? Can I reuse that? Yes, this is where inheritance is used. Let's see this example. While developing the calculator class, initially we have defined three methods: addition, subtraction and multiplication. Okay. The initial version of this calculator class serves three functionalities, which are adding the two integer variables, subtracting the two integer variables, and multiplying two integer variables. Okay. For these functionalities, this class works fine. Okay. Later, some period of time, I wanted to improve these functionalities, uh, and I want to add some more functionalities like calculating the power, calculating the modulus, and calculating the division value. Okay. Here I need to define these methods, and these addition, subtraction, multiplication are already defined, so I don't want to repeat the code again. I just want to use these functionalities, and I want to add definition for these functionalities. Okay, let's see how to do that. We have previously defined the class called calculator. Now I'm going to define a new class called scientific calculator that extends existing calculator class. Whenever we say extends, what will happen is the data members, the variables a and b, and the functionalities addition, subtraction and multiplication will be acquired to the class scientific calculator. Means from the class scientific calculator we can access the methods of calculator class. Along with those three methods, here we have defined some more methods: power, modulus and division. If we observe, we haven't defined the methods addition, subtraction and multiplication again in this class scientific calculator, but we can use that. How it will be possible? Because we have extended the calculator class, so we can access the methods of calculator class by creating the object of child class. See this? In the main method, I have created object for the child class, means scientific calculator OB. Okay. Using this child class object, here we are trying to call the add method. Add method belongs to this superclass calculator. Is it possible or not? Yes, it is possible because we have extended that class. And in the similar way we can access method subtraction and multiply also. Whereas this power, modulus and division belongs to this class only, and we can access that we know. Okay. This is the process of inheritance. Okay. In inheritance there are different types of inheritances. If there is only one parent class and one child class, then it is known as single inheritance. See this, here there is only one class which is parent class, and in the derived class there is only one derived class, class B. Okay. It is known as single inheritance. See this example. There is one class called class A with method A, and there is another class called B which extends A. As there is only one parent class and one child class, this kind of inheritance is known to be single inheritance. Okay. Let's see a program example. See this. First we have created a class called shape. Okay. What the class shape contains? It contains two data members called int length and width. Okay. While developing the class called rectangle, we are extending the existing class shape. Okay. What happens then? The length and width properties of class shape will be acquired to the class rectangle. Means from the class rectangle object we can use the variables length and width. Okay. See here, we have created object for the child class rectangle, and we are trying to access the variables length and width. Have we declared this length and width in rectangle class? No. Then why it is not throwing any error? Because these length and width are defined in shape and we are extending the class shape, so it will be possible. Okay. So we are able to assign values for length and width. Here we are assigning 5 and 6 for the length and width with respect to object R1, and here we are calling the method called area. This method area, what it will do is it will multiply length and width and it will return the result which will be the area. Here I have created two objects R1 and R2. The instance variable values for R1 are 5 and 6, and for the second object R2 the length and width are 7 and 8. Okay. Here initially the method area is called upon the object R1, so this length and width will be corresponding to the object R1, so it will multiply 5 into 6 and it will return result as 30. Okay. And when the second time the area method is called, it is called through the object R2, so this length and width represents the length and width of the second object R2. So what will be the result? It will multiply 7 and 8 and will return the result as 56. Okay, let's see the output. See this. While calling the method area for first time, the result is 30, and while calling the method area second time with object R2, the result is 56. This length and width corresponds to the instance variables of corresponding object through which the method is invoked. Okay, let's end this.